We're about to investigate the urban myth, 6 degrees of separation. The idea that in a world of more than 6 billion people, everyone is connected in just a few steps. That's to say that you know someone who knows someone who knows someone who knows someone who knows
me or anyone else on the planet.
Network theory, and some believe it will change our lives.
Networks are important because if we don't understand networks, we can't understand how markets function, how organizations solve problems, or how societies change.
6 degrees has the potential to change the way we fight terrorism, predict pandemics, and combat disease. It may prove to be one of the greatest scientific insights of recent times. And for that, there's one person to thank.
How can a population of dissimilar individuals suddenly synchronize?
How do fireflies flash in unison across great distances, or crickets chirp as one? How does order emerge from chaos?
We're so used to thinking that if there's a group following acting in concert, it's because there's a conductor for the orchestra. But that's not necessarily so. There's 100 billion brain cells acting like the most complicated thing in the universe, and there's no cell that is the master conductor of the brain. The brain does it as a group. The heart has 10,000 pacemaker cells that tell the rest of the heart when to beat. Who's in charge? Who's the pacemaker for the pacemaker? No, nobody. You're only 6 handshakes from any person on Earth.
And I started to think maybe it's true that this 6 degrees of separation phenomenon applies in the real world. And what are the consequences, if that's true, for the synchronization of crickets, for the way that disease spreads throughout a human population?
And it was almost a scary thought, because we could see, when he suggested it to me, that we were on the brink, if we could do anything sensible, of a whole new science.
Scientists would look at the problem from a different angle. For Hungarian physicist Laszlo Barabashi, understanding networks held the promise of predicting the future.
What could do to predict the future? I realized that what is missing from Asimov's thinking is the network, the structure and the behavior of the network. Because events are never isolated. They depend on each other. They interact with each other. So we need to understand how they interact.
To understand these interactions, Barabashi needed a network that had been thoroughly mapped.
The major problem was that the data was incredibly difficult to find.
Here was a huge network he could map by tracing the links between web pages. No one directed the growth of the web. Anyone could put up a site and link to wherever they liked. So the expectation was that the structure would be entirely random. In these early days of the web, long before the familiar super sites of today had emerged, Barabashi's study had glimpsed the future.
It predicted the potential for the existence of huge hubs, like Amazon and Google and Yahoo turned out to be.
Barabashi's hunch was that behind this pattern, there may be a deeper truth lurking. Here was the secret behind almost every network. The structure that nature uses to spin its webs. And once it could be seen, it revealed networks have peculiar strengths and weaknesses, with implications for all of us.
3, 4, 5, 6. 6
There
degrees
you
of
are.
separation.
There you are.
Perfect.
From urban myth to maths equation to a daring new approach to fighting disease. This is the promise of network science, a new way of seeing our world.